Hello, STEM Nation. Jeff here, and welcome to episode number 2 of STEM on Fire, where we interview practicing professionals in the area of science, technology, engineering, and math. Let's start by thanking our sponsor, Audible. Audible is offering a free audiobook at stemonfirebook.com. That's stemonfirebook.com. Go there to get your free audiobook. If you're looking for a good audiobook to listen to, I recommend The 7 Habits of Highly Effective People by Stephen Covey. Let's get fired up today with our guest, Aaron, and I hope our chat will help ignite your passion towards a STEM career. Aaron Hartwig is a 2016 graduate of the University of Wisconsin-Milwaukee with a Bachelor of Science degree in computer engineering and currently pursuing a master's degree in electrical engineering. He had 2 internships during college at YI Software and Scanalytics. Upon graduation, Aaron took a full-time position at GE Healthcare in a design group doing digital logic design, and currently resides in the Milwaukee, Wisconsin area. Welcome to the show, Aaron. Take a moment to fill in any gaps and share a bit of your personal life.
Yeah, thanks for having me, Jeff. You covered most of my college and professional career, so I guess I would just add that I grew up in rural Leroy, Wisconsin. It was a town of about 300 people. My backyard was a cornfield. So moving to Milwaukee for college was a pretty big deal for me, and I actually didn't write a line of code until I got to college. So, yeah. Little fun fact.
Okay. Hey, thanks for filling that in. So let's get right into it. So for someone not familiar with computer engineering, can you give some examples of career opportunities? And then we'll delve into your specific area of expertise.
Yeah. So computer engineering is kind of a hybrid of computer science and electrical engineering. So you'll take classes ranging from, algorithm design and operating systems to the more computer engineering focus of computer architecture, maybe embedded systems, and then you can get all the way to electronic design and like circuit analysis and things like that. So it kind of covers the whole spectrum. And as far as career paths, you can really take it as far software, as far hardware as you want. I have friends who graduated from the program that are software engineers, and they build like enterprise web apps and things like that. And I also know friends that are more followed along the lines of what I did and went into hardware design. So it leaves a lot of doors open for you.
It sounds like computer engineering, if you're not sure if you want to be pure hardware engineering or pure software engineering, computer engineering might be the way to go for you.
Yeah, definitely. That was kind of why I initially jumped into it, was because it didn't really seem like it was going to close many doors for me.
So why did you choose computer engineering over any of the other disciplines like software engineering or mechanical engineering or even, chemical engineering?
Yeah, so I have a very roundabout story for how I even ended up in the College of Engineering. I actually spent my first year at UWM in an IT program, basically a professional IT program, learning about networking, kind of some high-level software stuff, information theory. I took an intro to computer science class that I really, really enjoyed. And like I said, I hadn't written a line of code till I got to college, so I didn't really know what was all out there. And then I really liked this computer science class, so then I took another one my second semester, and then I really, really liked it. So I decided, okay, I need to meet with somebody in the College of Engineering and see if I can switch to computer science, because these guys, they know about computers. I went into IT because I liked computers. I thought that's what people that liked computers did. And once I spent a little bit of time, a semester or two in the computer science program, I realized that, computer scientists, they use the computers a lot, and they understand it from a software perspective, but I kept wanting to dig deeper. I look at components in computers and kind of wish I understood what, why that chip was there and what it all meant, because it just looked kind of beautiful. And then I saw that really electrical engineers were the people that were designing computers for the most part. So at the hardware level. So then computer engineering was kind of a happy medium where I could kind of fulfill both roles and, dabble in electives from each discipline and really figure out what I wanted to do.
Okay. Hey, that's a great background. Let's move into your specific area of expertise now that you're working full time.
I work on FPGA designs. So an FPGA is a device that has essentially programmable logic that I can write a hardware description language for. So I write VHDL, and it creates basically digital circuits that represent the logic that I express in the code. So at a high level, that's kind of what I do. So you work on a lot of the FPGA stuff kind of happens in parallel, whereas your CPU will go really, really fast, but do one thing at a time. And FPGA handles things at a much slower rate, but can do hundreds and dozens of things in parallel.
Yeah, the FPGAs, and when I went to school, FPGAs, Field Programmable Gate Arrays, were not even in existence when I was in school. So one thing to note, STEM Nation, is when you get out into your career, as you transition through your career, there's going to be new technologies that you're going to have to get up to speed on. So it's going to be a never-ending learning process, which is actually pretty cool. Every day always seems like it's something new going on and something new to learn. Aaron, what would a typical workday look like for you, or a work week look like? What could a new professional expect in the real world?
My number one thing is probably thinking about designs, debugging kind of my ideas. Usually what I'll do is I'll kind of decide on, let's say, if I go into the office tomorrow, I'll figure out what problem I'm going to try to solve first. And then usually I'll spend some time trying to draw some diagrams and build out my mental model and to figure out if I understand what I'm actually trying to accomplish and kind of make a plan for how I'm going to try to accomplish it. And then usually I'll go into the actual like coding and simulation of that design to see if what my initial thoughts were kind of solve the problem, or if I had any maybe blind spots and things like that, and cases I didn't think of. So I would say I spend the majority of my time iterating over designs and simulating and kind of revising diagrams and trying to draw. And the next biggest thing I would say is interfacing with teammates. So I spend a lot of time actually working with a software team in France. So usually my mornings are actually spent emailing and instant messaging with them, because that's kind of our big time overlap, since they're 7 hours ahead. So it's usually answering questions they had for the day, responding to their emails that came in while we were sleeping. And those are probably the two biggest functions I do every day, is work on my own designs and then try to interface with the people who are using those designs and have to kind of write software for those designs.
Yeah, that's a great overview. And one thing, STEM Nation, to realize is that most companies are global, and you're going to be working with global teams when you get out there. And communication skills, email skills are going to become very important. They are very important already, and they're going to become even more important as the world turns here. Aaron, let's get specific here. And what is one thing that has you fired up about computer engineering, and where do you see it headed?
I am really fired up about AI and machine learning. So I really enjoy computer science and programming and math, and using these kind of mathematical constructs to solve real world problems. And then it's also an exciting time to be an FPGA engineer in this field, because there are so many companies that are using these FPGAs to implement their AI and machine learning applications, because they're really good at handling matrices and doing a lot of things in parallel. So it's kind of a best of both worlds, because what I'm interested in has really come to the forefront of technology. It's on companies' minds. Big companies are pursuing it. Like consumer companies like GE is trying to add machine learning to everything. And then you have companies like Intel and NVIDIA who are building specific hardware to accomplish this in the best way possible. So it's a really fun time to be an engineer with this skill set.
Yeah, and one of the terms that Aaron used, AI, that's artificial intelligence. And artificial intelligence is showing up everywhere you turn. Even I was talking to some actuarial students and some folks in the actuarial profession, and they're looking at artificial intelligence and just deep learning to figure out things in their field. So it's showing up everywhere. And field programmable gate arrays are a big part of that, as well as, like Aaron had said, NVIDIA GPUs are a big part of that. And it's a pretty exciting field. So thanks for that, Aaron. I agree. That's got me fired up too in the area of computer engineering. Let's change gears here a bit, and we're going to move into a story, an aha moment that you've had, something that might help out our STEM Nation. Can you take us to a moment in time of an incredible aha moment you've had at work or your personal life, and tell us the story and how you turned that aha moment into success?
So one of my biggest aha moments that's stuck with me was, as I mentioned before, I kind of had a winding path to get to the major I ended up with. I think I changed my major 3 or 4 times in the first 2 to 2.5 years of my university time. What really kind of sunk it in one day was when I was in an ABET review. So ABET is when you go to an engineering college, the ABET accreditation is it holds the most weight and says that your university has a legitimate program and things like that. So the computer engineering program was going through their accreditation progress again, or actually all the engineering programs were. So I was a brand new computer engineering student. I had just kind of figured out, hey, maybe this is what I want to do. And there was a computer engineering professor from Ohio State who was talking to a group of us and was kind of explaining, how computer engineers fit into it all. He was like, to a computer scientist, a computer is a box and a network is a cord. That kind of stuck with me because I knew a lot of programmers from my programming classes and computer science classes, and that's just kind of how they thought about things. They didn't really think about stuff too much deeper than, compiling their Java or, things like that. And that wasn't ever really satisfying to me. And I kind of wanted to know a little bit more about how the network worked, or, the computer's a box, but what's inside the box? So that kind of stuck with me and solidified that, hey, this is where I want to be.
I think with computer engineering, you're down at the low level, or you can be down at the low level. I guess you could always go into, application software. But computer engineering, since you're learning both the electrical, the hardware side, and the software side, you can get down to the low level area of driver development, reading and writing registers right on the processor or on the board itself. And that's pretty exciting. So I think if you have those skills to do both, I think you're very valuable to most employers. So Aaron, we're going to transition here. We're going to go to a topic that's front and center on the minds of our STEM nation and discuss what it takes to get through college and be successful with these rigorous STEM curriculums. If you could go back in time, what would you tell your 18-year-old self as you're heading off to college? Some things that you wish you knew back then, or even knew back then, that would help our STEMers launch into college successfully.
I think my number one that, and professors and advisors will say this to you from day one, and it really does matter, is starting homework sets as early as possible, because a lot of what your work sets are in a STEM degree, especially engineering, are math and physics problem sets where you'll get, a handful of problems assigned, and then next week they'll be due. And you don't want to wait and start the project or start the problems the night before, because it doesn't really give you time to learn the material and ask questions about it and actually understand it. So that would be my number one, because if you're just cramming assignments in the night before, you're never really digesting it and really understanding what you're doing. And probably my second thing would be, as you progress through your degree, when you kind of get into your sophomore and junior years, form a core group of friends that you can, do homework with, make project groups with, and that makes everything a lot more enjoyable, and you can really lean on one another. So building a support structure, I think, is important too.
Yeah, I think that's great advice, especially starting homework early. I think a lot of students, most of the folks going into STEM, STEM curriculums are fairly bright. And a lot of times in high school, they didn't really have to study a whole lot because the curriculum's not that difficult. And a lot of them pretty much get blasted when they get to college, and just the amount of homework and what's required and what's needed just hits them very hard. So if you haven't developed those study skills, kind of time management in high school, it's going to become difficult in college. So start learning that now and start doing your homework early. If you think it's going to take 3 hours to do your homework, it's probably going to take 9 hours to get your homework done. So start early. If you get done early, then that's great. You can go off and do something else.
Yeah, definitely.
Aaron, let's go to some skills or attributes that you think are needed for STEMers to be successful when they transition from college into their careers. You're kind of a recent graduate, so is there any skills that you had to develop or you wish you would have had coming out of college?
My number one skill that would be useful to a new grad isn't something you necessarily get in college. It's something I think you can develop personally, but it's being curious and being interested in what you're trying to work with or learn, kind of keeping up on maybe the state of things. Like you had mentioned, the field's constantly changing. What the guys were building 10 years ago look completely different than what the stuff we're working on now. So if you're not kind of always looking around and even just casually reading up on what are the new products coming out, what are, the new tactics people are taking, you'll kind of fall behind. So I think being curious and open-minded and just having a good attitude about maybe accepting that you don't know something and, being willing to learn, that goes a long way in everything from working on your team to growing your technical depth, I don't know. I just feel like that's the most indispensable skill you could have.
Yeah, I think you hit on one, that attitude. Attitude is so important. You have to have a good attitude, and you're not going to know everything coming out of college. And even when you're a practicing professional, there's just no way you can know everything. So it's okay not to be the brightest one in the room. In fact, you're going to learn more if you just sit and listen to other people and pick up what they have to say. Take their advice. So, Aaron, are you ready for the lightning round?
I hope so.
You hope so. All right. What's the best piece of advice you've ever received?
I think the best piece of advice that I ever received, that it's okay to geek out about something, just to have something that you're almost obsessive with. It might not seem cool, to really actually be passionate or care a lot about something, but just no matter what it is, if it's woodworking, if it's web development, if it's kayaking, if it's fishing, just kind of have a passion, and it just makes you way more interesting of a person to talk to and be around. And
what's a personal habit that contributes to your success?
Kind of going back to the skill I said before, I think it's just that I'm always curious and I'm always ready to listen to what somebody else has to say, whether it's feedback or, hearing about an article that they read, just being flexible and having a good attitude.
What's your favorite internet resource or phone app, and why?
My favorite internet resource is probably Stack Overflow, because it helps in all aspects of programming. They've got a lot of VHDL stuff on there. They've got, pretty much all the languages that you'd ever want to work with. There's a community of people there ready to help you. So definitely Stack Overflow.
Yep, Stack Overflow. That's pretty popular for a lot of college students. What is one book you recommend, and why?
I Was, which is Steve Wozniak's autobiography. I'd recommend it just because Steve Wozniak was kind of the engineer who built Steve Jobs' first computers, I guess. And I call him Steve Jobs computers because he kind of made them into like a beautiful thing that people wanted. But Steve Wozniak was just kind of the perfect embodiment of a computer engineer. He, did all the hardware design. He wrote all the code that, so low level, all this stuff, wrote, the basic compiler, all these different things. And that was just kind of like the embodiment of what a computer engineer can do. And I just really look up to him.
All right. Hey, Aaron, we're going to be wrapping up here. I appreciate your time. But as we wrap up here, can you share a parting piece of guidance for STEM Nation? And then we'll say goodbye.
Yeah, stick with it. It's tough. And a lot of times you don't really understand why you might be doing something or how it's relevant. But as you go on, things kind of snap into place and into perspective, and it's worth it.
All right. Hey, that's great advice, Aaron. And with that, we'll say goodbye. I hope you enjoyed our discussion today with Aaron. Head over to STEMonFire.com for more information, and tune in next week where we interview Kayla, a biomedical engineer. Until next time, I hope this chat has helped ignite your passion